if we look at this line, which is the red one, which is described by the equation y equals minus 1x plus 2, then that shows us that there are an infinite number of combinations of x and y that make this statement true. But now if we add another line onto that same graph, so in this case, the second one we were looking at y equals 2x plus 1, then also this one has an infinite number of solutions that make it true, but there's only one combination of x and y that make it true for both equations at once, and that's the intersection of the two lines. So in this case, it's x equals about a third, it looks like, I can't tell very accurately, and y is about 1 2/3. And so we can tell that from looking at the intersection on the graph. Oops. So let's just make that small because I have other things to say here. Okay, so bear that in mind. So let's write it out. So if we've got two equations with two variables, which is our case here, so that means there's a single solution that works for both. Let's write it that way. And that is the intersection of their lines. And of course this is only true if the lines are parallel, then that doesn't work. So if the slope is the same, the lines are parallel, so that means there's no intersection and no solution that works for both. But you could also, so either you can look for the intersection or you could solve it arithmetically. And that is going to be much more precise probably than just drawing some dotted lines on a graph. So what do you do? So first of all, you isolate x in one equation. So I don't really care which way around you do it. You could do y first, don't mind. And then you can replace x in the second equation with this expression, sorry. This maybe doesn't make very much sense in the abstract, but you'll see in a minute. An expression, and you can solve for y. That gets you the value of y. Then you've got the value of y, so then you can replace that y in the first equation and solve for x. And then you need to check and see that you've done it right by replacing the values of x and y in the two equations and see whether they are true. So let's do it and you'll see what I mean. So for example, let's look at these two equations we've just got. So we've got y equals 2x plus 1 and we've got y equals minus 1x plus 2. Those are our two equations. So step 1, isolate x in one equation. So I think I fancy isolating x in this equation here, so that would give us y minus 2 equals minus 1x. Subtract 2 from both sides to get rid of that plus 2. And then we divide both sides by minus 1. That gives us y minus 2 over 1 is x. So x is equal to minus y plus 2. This minus distributes itself between the two. Alright, so now we've got this. And I'm going to take it over here to the other side, and everywhere I see x, I'm going to replace it with minus y plus 2. Which is to say that y is equal to 2 times minus y plus 2 plus 1. So y is equal to minus 2y plus 4 plus 1. So y is equal, so we say y plus 3y, sorry, plus 2y equals 5. So 3y is 5, y is 5 thirds. Great, so now we know what y is. We can replace over here everywhere we see a y. So we know that x is equal to minus y plus 2. So everywhere we see a y, we can replace it with 5 thirds. So x is equal to minus 5 thirds plus 2, which is to say minus 5 thirds plus 6 thirds, or 1 third. So there's our solution. So x is 1 third, y is 5 thirds, and that's what we saw when we looked at the graph here. That's our solution. So now finally we just need to check by replacing our values there. So is 5 thirds equal to 2 times 1 third plus 1? So that would be 5 thirds is equal to 2 thirds plus 3 thirds. Good. And over here, if we check, 5 thirds equals to minus 1 third plus 2, so that would make 5 thirds equals minus 1 third plus 6 thirds, which is true. So that checks out. Okay, so we just find x is equal to something, and then everywhere we see x over here, we replace it with that. So that means we've only got y's in this equation, and that means we can solve it for y. And then we know a value for y, so we can replace y with that in the other equation and work it out.